Now this part is called basic rules, but it's really just a review of things we've done before. Here are some basic things you want to do when your integral doesn't fit one of the known standard forms. You may need to expand your you may need to separate the numerator, so break this up into two fractions. You may need to complete the square, always fun. You may need to divide out improper rational functions, and you're going to do this when the power of the numerator is greater than or equal to the power of the denominator. You may need to add or subtract terms in the numerator. You see this will give you a U to U situation plus something you'll be able to write. Trig identities. Oh goodness, you just need to know them. Or you may need to multiply by the Pythagorean unit. And this one, of course, will take a number of steps. Now, the one thing you can never do is separate the denominator. Do not do this. Okay, 1 over 1 x squared plus 1 is not 1 over x squared plus 1 over 1. So let's look at three different integrals. If I look at this integral right here, the only difference here is I'm adding the numerator, but it's going to give me three very different answers. So let's look at A. This is 4 times the integral of dx divided by x squared plus 3 squared. Right, this is my inverse tangent function. So this is 4 times 1 over 3 inverse tangent of x over 3 plus c. So I'm going to rewrite this as 4 inverse tangent of x over 3 plus c. Now let's look at B. Let me let u equal x squared plus 9, in which case du is 2x dx. So x dx is du divided by 2. So this integral becomes, I'm going to factor that forward, the integral. Now x dx is du divided by 2. So I'm going to put this on the outside, and then this u. So this is twice the integral du over u, which is 2 times the natural log of the area of u plus c. Plugging u in, this gives me 2 times the natural log of x squared 9 plus c. And of course we can rewrite this as the natural log of x squared plus 9 plus c, but you don't really have to. That's just kind of fun. Now let's come over and do this one right here. C. The numerator is the same power denominator, so I'm going to want to divide x squared plus 9 into, now I'm going to factor this 4 out. I'll tell you what, let me not in this case. 4x squared, I don't have to this time. So x squared goes into 4x squared 4 times. So this is 4x squared plus 36. Subtract, that goes away, so this is minus 36. So this is my remainder. So this is going to be minus 36 over x squared plus 9. So I write this whole integral as the integral of 4 minus 36 over x squared plus 9 dx. So this becomes 4x minus 36. Now it's like we've done this one before, haven't we? 1/3 inverse tangent of x over 3 plus c. So let me clean this up a little bit. This is not 3 but 4. 4x minus 12 inverse tangent of x over 3 plus c. Now sometimes you're going to need to do some sort of funky substitution. This doesn't look like anything really straightforward, but I see I've got a square root of a squared minus a function of x squared. So for this one, what if I let a equal to 4. So that a squared is 16. So if I now let u squared equal to x to the 6, I'm doing this one kind of backwards. So this tells me u is cubed. All right. So I can rewrite this as the integral of what? Well, first of all, I need to come up here and du, don't I? So du is 3x squared dx. So x squared x is du over 3. All right, so this becomes x squared dx, which is du 3, divided by the square root of a squared minus u squared. Now this is 1/3 times the inverse sine of u over a. Now I need to redo this. This is 1/3. Writing all that out. Inverse sine. U in this case is x cubed. A is 4.